generally section 410 covers a lot of forms of differential equations that don't show up earlier in chapter 4. But the reason this second half of it happens now is because this involves series. And that's a good lead into chapter 6, because chapter 6 is all about when you get solutions that are series. So what we've got here is something that's nonlinear. Right? We've got a y squared in this, and it's an IVP. And what we're going to do is that if the solution y is analytic at 0, where being analytic basically just means all the derivatives of y exist, then you can express it using a Taylor series expansion centered at 0, which is what this is right here. So the initial conditions here actually play into this quite a bit, because as you'll see with these subsequent derivatives down here, knowing y of 0 and y prime of 0 is going to go a real long way. So we want to get the first 6 terms. So we should be able to get the first, second, like these two we should be able to get already. The third, we can basically get this one, right? Because then you're just going to substitute in 2 for y, right? You don't have to take any derivatives to get this. But then I guess we'll need the third, fourth, and fifth derivatives to get those fourth, fifth, and sixth terms. So that's these things here is just getting the third, fourth, and fifth derivatives, where really this is just implicit differentiation, where there's y double prime up there. So y triple prime should be the derivative of that with respect to x. So, all right, well, derivative of 1, 0, but then the minus y squared, you bring down that 2 times y and then times the derivative of y, which would be dy dx or y prime. This was easier to write and fit it on the page in prime notation, which is why I went that route. And plus, these look really messy if you use Leibniz notation and try to write that equation out. Then fourth derivative, which that's usually the point where you stop using the primes and start using the numbers in parentheses. So that was what I decided to go with there. But the fourth derivative would be the derivative of the third, which is that, the minus 2y, y prime. So then I just brought the minus 2 out and then did a product rule on the rest of it. Then fifth derivative would be the derivative of this thing, right? So I still got that minus 2 out there. Then product rule with this, right, which would end up being these first 2 terms, right? Then here you would just bring down the 2 times y prime, then times the derivative of, I guess, what's inside the parentheses, so y double prime. You do get to combine terms a little bit here, right? You combine these two together, and that's what I did here. And I said, all right, inside the brackets, it's y times y triple prime plus 3y prime y double prime. The next step is evaluating all those derivatives at 0. And I guess if I go up toward the top, we already know y of 0, y prime of 0. Y double prime of 0 is pretty quick, because all you really have to do, I guess you can see it there or you can see it there, you just have to sub in y of 0 for the y. So you sub in a 2. So it's 1 minus 2 squared, you get negative 3. So it's right there. The other ones, you're subbing in based on what's up here and what you already know about y and y double prime, and then subsequently you got a y and y prime, then a y double prime, then here you do y triple prime. But we'll kind of get those as we go. So y double prime, now we have it. Y triple prime, so y of 0 is 2, and then y prime of 0 is 3. So just sub in the 2 and the 3, you get negative 12. And then fourth derivative, so okay, we need y double prime this time. We need a y, we need a y prime. Simplify that, you get negative 6. Fifth derivative, I guess you need y, y prime, y double prime, and y triple prime in different spots, which we're just subbing those in, right? There's the y triple prime, there's the y prime, there's the y double prime. You simplify that, you eventually get negative 2 times negative 51, which is 102. Then once you have those, then we can kind of follow the formula from up on top, which I just reproduced right here, where then y of 0 is 2, y prime of 0 is 3, y double prime is negative 3, right? So I'm just subbing all those in, getting those first 6 terms in there. And then I just simplified to the extent that I could, right? 3 over 1 is 3. That's a negative 2, right? That's a negative 1/4. So I just simplified those little parts. But then basically here it is, right? Here's the solution, or at least the first 6 terms of it.